Hey everyone, how's it going? Welcome back to another great episode in the Intro to Coding series for Python. In this episode, we're going to go over generators. Last episode, we went over iterators, and generators are basically just a way to make iterators very easily. So pretty fun, actually pretty useful once you figure out how to use them. So yeah, let's just jump into it. Boop. All right, here we are. So, generators, like I said before, it's just a way to make iterators very easy. So, let's start writing a generator. All right, so we're gonna start typing def mygen, and yes, generators are actually just made from functions. We already know how to make functions, so it should be pretty simple. So, the way generators work is they use something called a yield statement. So just to kind of iterate this, just to show this a little bit more easily, let's do this. Let's do this, yield 2 and yield 3. That's it. We've created our first generator. How do we use this generator? Well, the way we use this is, let's just type in gen and mygen. We'll just call the function, and then let's start printing some of the iterator values. So just like before, it is a type of iterator. So we are able to use the next, as you saw from last time. We had like the next thing within our class, and yeah. So let's run this. Okay, we get first, because this happens first, right? And then we hit the yield, and then we hit second, and then we hit the yield, which just returns the 2. So that's how this is being printed. So this is printing the 2, this is printing the 1, this is printing the 3, and this is causing the stop iteration error. Okay, pretty simple, right? Now, let's go over why this can actually be super powerful. So to better illustrate that, I'm going to copy in a bit of code that I had pre-prepared for a basic simple counter. So let's create a counter here, and we have our example here. So I'm just going to run over this super quickly. We created a class of counter. This counter has an init function, which takes in a value that it's going to count up to. Then the next function, it gets the count. I guess we'll go over iter first. Then the iter function sets count to 0, then returns self. This is just the same as you'd have to do it for any iterator. Next, gets the count. Then it sees if count is at the maximum of 2. If it is, it causes this exception or this error like we saw right here, this stop iteration error. We haven't gone over this before, but that's just basically what happens. This is called with a normal iterator or a generator as well. Like if you go over too many things in a list or something like that, one of the things that's happening is this stop iteration. Then we increment count, and then we return x. That's it. Pretty simple. So when we run this, we can see that this one will error, and let's just, we can keep that other stuff. Actually, we can't keep this one because this one will error. Okay, we run this, and I'm sorry, let me just do that just because it'll be a little bit clearer. Okay, so we get our 0, 1, 2, 3, 4 because we're going up to a max of 5, but remember, it's not inclusive. So bam, we've got our 5 values printed out. And again, we hit this stop iteration error. So if we just comment this out, bam, right? And if we want to be able to get this to 10, we can do this. And let's just put this in a for I in range of 10, print next counter. And let's just get rid of these. Bam, we can get up to 10, right? If we change this to 11 though, it will error. Okay, makes sense. Now, what is so like this is good, right? But this takes what? A number of lines I don't know, 23 to 36, so 13 lines to code. So we can actually write this with the generator though in like 3 or 4 lines. So let's do def count up 2, and then all we're gonna do here is just go for I in range of 2, yield I. That's it. We did it. This is the exact same as this. So just to prove it, let's do our whole thing here. We're gonna go count up to 10, and then we will for I in range 10 print next of counter, and then let's just comment this out so that we don't get that one being printed. Bam. We get the exact same stuff, but we've done it in 3 lines instead of 13 lines. So we've shaved off 10 lines. Pretty solid. Now, you might argue that like this can be more useful because you can add little nuanced things here or not have it ever cause an exception and just keep counting if you want to. And that's true. That's definitely true. But there's still some really useful things, and like this is obviously so simple, right? It's very clear what it's doing. It's counting up to this value, and it's just going to yield that value every single time you call next. Pretty simple, pretty powerful. So another example that we can do here is something that maybe is like adding a value, right? So if we want to have a counter that just keeps adding to something, we can create that. So let's create add 1. Let's call it like this, and we're gonna give it a max. So one thing you can actually do in Python is give a default value. So if something isn't passed, it will just use that default value. So we're giving a default value here of 0. So let's just let's give n equals 0 while n is less than max. We are going to add 1 to n, and then we're going to yield n. Okay, and now we can have a whole new counter. So counter equals add 1 with a max of 10. Well, let's make a max of 5 so we can reach it easily. And that's it. We have our counter. If you call next on this, it'll just keep counting up. Simple as that. Pretty sweet. And if you didn't want to have a max, right, you could just say, well, true. N plus equals 1, yield n. Because it'll always be true, and it'll always yield at that point, so you can just keep going forever. So another thing that we've done on this channel is talked about Fibonacci sequence, how to do the Fibonacci sequence. And there's actually a really cool way you can use generators to do the Fibonacci sequence as well. So I'm going to type this out, and then I'll explain it as I kind of go, I guess. So Fibonacci, hold on. I think I spelled this wrong before, so let's make sure I don't spell it wrong again. Fibonacci. Okay, it is 2 C's, and I apologize for the last time where I spelled it incorrectly. My bad. Okay, Fibonacci numbers, and let's just give it some like 2 value, just so we don't go forever. So we're gonna do x, y equals 0 and 1. This is actually a thing you can do in Python. I don't think we've ever gone over it, but you can define multiple variables on the same line, and then whatever's after the equals, you just have separated by a comma. So the x will be given this 0, and the y will be given the 1. Pretty cool. Now we're going to do for underscore in range of 2. Underscore just means it's a value that whatever the range is, or the value from range, we don't really care about it. So we're just going to loop over this many times. Kind of simple. It's just kind of like, it's basically the same as like a while loop, but you don't care about the counter at all. So we're going to do the double thing here again, and we're going to do x, y equals y, x plus y. And then we're going to yield x. So again, this here, so x will be equal to what y was equal to, and then y will be equal to whatever x was equal to plus whatever y was equal to. I know, a little weird, but it's a simple way to write it. All right, now we have all of the Fibonacci numbers. That's it. That's the whole thing. So again, just to prove this, let's just do Fibonacci numbers, and let's go to 50. And then let's, for I in range, I guess we don't need that, right? For underscore in range of 50, let's print next of fib, and let's see what happens. There we go. We went all the way up, and we can see the start 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, right? We've gone over these numbers before, we've seen them before, but pretty cool. Like, our whole Fibonacci was in like 5 lines of code, and we've kind of done the whole thing. So it's pretty cool, pretty powerful. So this is just kind of a basic idea of how generators work. Just add a yield and the function becomes a generator. It's pretty cool that you can just kind of make something that you can iterate over so easily. And you know, it's not something that you're necessarily going to use every single time you code, but if you find the right place for it, like if you have to count up to something, or the number of turns, you know, rather than having just some random thing adding 1 somewhere, you can have just a reference to a generator, which is keeping track of the current level or the current turn or something like that. That being said, it's kind of like having a normal iterator for that can be useful as well, because you can add helper functions and stuff like that. But still, this is still a very, very useful thing that you can use to create some pretty powerful iterators really quickly. So that is about it for this episode. I hope this was useful, and I hope you learned something. Even if you don't use generators a lot, again, I think it's just useful to know what the language can do, and that's what we went over today. So again, thank you so much for watching. If you wouldn't mind dropping a like down below and subscribing, it's down here, I think, right there. So feel free to subscribe, and I hope to see you in the next one, where we're going to go over modules, which is a way to kind of make some code and keep it in a separate file and then use it in a different file. This is kind of, I always say things are powerful, but this is one of the things that actually allows you to make something, put it away, and use it later, or use other people's code. And yeah, you can do some really cool stuff with it. After modules, we're going to go over files, and then we're going to go over something called pip, which is a way to get like basically modules that are built outside of, or not by you, by the world. It kind of unlocks a lot of things. It can be really, really useful. And then after that, we're going to go into APIs, how to use an API. And then finally, we're going to make a hangman game, so you can play against the computer, and it will be using an API. It will be getting some data from an API, the words, so that we can't just, it's not just like a single word, so we guess every time and we're always right. So yeah, it should be a lot of fun. Yeah, well, thanks a lot for watching, and remember, never stop learning. Cheers.